Hey all you crazy cats and kittens. In this video we'll be discussing section 14.2, translating and reflecting trigonometric graphs. Alright, so more specifically we're going to be talking about the tangent function in this video. Alright, so graphing tangent functions using translations and reflections is similar to graphing sine and cosine. Alright, so just like with all of the other functions that we've dealt with this entire year in Algebra 2, we have these a values, we have these h's, these k's. All of these numbers, depending where they are put, hold some different meaning for us as far as the graph is concerned. So I'm going to go ahead and flash us back to some key concept boxes from 14.1. Alright, so here's what the graph of tangent of x looks like. This is just my parent function, tangent of x, and they have a couple of characteristics listed for us. Alright, so I have a domain that is all real numbers other than odd multiples of pi over 2. What that means is we have those vertical asymptotes. Alright, those lines we approach, but we never get there. So we need to keep that in mind when we sketch our graph. The range is all real numbers, so it does not have an amplitude. Alright, and the graph has a period of pi. And then the x-intercepts occur at these values. Alright, so here are the small, tiny little formulas that I need to keep in mind. Alright, the period for tangent is slightly different. It's pi over the absolute value of b, not 2 pi over b. And vertical asymptotes occur at odd multiples of pi over 2 times the absolute value of b. And then when I have those a and b values where they're greater than 0, a is greater than 0, b is greater than 0, there are x-intercepts, the x values where the asymptotes occur, alright, and the x values halfway between the x-intercepts and the asymptotes. So we're looking for these, critical points right here, and those occur at pi over 4b, comma a. Alright, so they are at a halfway point, which is at either a or negative a. So we're just kind of keeping in mind how we chop up a graph. Alright, that's just a little bit of review, so it's best to just go ahead and jump into an example. So, combine a translation and a reflection. The graph of y equals negative 3 tangent of x plus 5. Alright, so I would go ahead and identify all of your parts here. The period is pi, so keep in mind you are doing pi over b. Alright, that's my formula, pi over the absolute value of b, and where here, b equals 1. Alright, there is b. We don't see it, so it is a 1 in this case. And then I have my horizontal shift. There's nothing grouped inside with x right there, so that is 0. My vertical shift, k, equals that 5. And then that negative 3 is my a value, which is not listed right now because that a value doesn't have the meaning that it does for sine and cosine. We don't have an amplitude here. So, step 2, draw the midline. Alright, that midline occurs at that k value. And then find the asymptotes, or the key points, of our graph. So I follow all of the steps. So for my asymptotes, alright, I compute using my little formula here for asymptotes, and I get pi over 2 and negative pi over 2. So finding the asymptotes, note the asymptotes are not shifted. This is because there's no horizontal shift. If there was a horizontal shift, they would be shifted as well. This is just a vertical shift. Alright, so on y equals k, those points would be 0, 5. And my halfway points, I'm adding that 5 to the y values as well, and I get those points. So I'm also going to reflect the graph because a is less than 0. It was that -3. Alright, so the graph is reflected in the midline. So instead of my graph looking like this, it's going to look like this instead. Alright, and so what that does for my values, I need to keep in mind that it changes my x values and y values here. So when I originally had pi over 4 comma 8, it's going to be negative pi over 4 comma 8. And where I had negative pi over 4 comma 2, it's going to be negative pi over 4. So here's what our final graph should look like. Plotting all of our points. So it's hard to, figure out these examples when they list out the instructions without giving you step by step. So the very first thing that I would do is, you have your graph drawn. I would, draw that midline, then I would draw those asymptotes, and on your midline where that, kind of center should be, and then you draw those halfway points, and you should know whether it's positive or negative. So if it was if A was positive, you are going to kind of have some points up here. If it's negative, like our graph, we know our points are going to go like this. Alright, so we can get down a rough sketch without knowing those exact values at first. That's going to help. Alright, so draw the graph for the key points. So here's example 6, glass elevator. You are standing 120 feet from the base of a 260-foot building. This is a very, very, very typical setup for a trig problem that you would see on the ACT or something like that. Alright, you watch your friend go down the side of the building in the glass elevator, write and graph a model that gives your friend's distance in feet from the top of the building as a function of the angle of elevation theta. Alright, so here is my distance, and I know that the entire building is 260. Alright, that is where that 260 minus d comes from. Alright, that's the remainder here. I'm going to rewrite it so you can see it. 260 there as the height. So, we're trying to write our function in terms of theta here and d. So let's go ahead and hop to it. Use the tangent function to write an equation relating d and theta. Okay, so tangent, it's going to be helpful to always write out so ka to a. It's the very first thing that I always do when I see a trig problem, a triangle. So we're using tangent because this is the opposite side and this is the adjacent side. We don't have the hypotenuse, so I'm going to be dealing with opposite and adjacent. Alright, so we're going to set that up. Tangent of theta equals opposite over adjacent, 260 minus d over 120. And so then I go ahead and I multiply each side by 120 times 120 times 120. Alright, those cancel out, so that is how I get that line of work. And then I subtract 260 from both sides, and I get d. Alright, but it is negative d, so I take one more step, and I multiply each side by -1, or divide each side by -1, and that changes my signs here. Alright, so I actually get distance in terms of theta. That's exactly what I want. So here is my adorable graph. And now I have this a value. Here is my b equals 1. And is this h or k? Do I see parentheses? No, so this is my k value. Alright, so using that knowledge, let's see if we can go ahead and do these guided practice and get these graphs. So it's going to be helpful for you to label A, B, H, and K, and then figure out all those parts and graph each step one at a time. Alright, if you guys have any questions for setting up any of these graphs, so with 14.1 and 14.2, we're really just graphing these three functions in a different, mode. On our calculator, instead of our mode being in degrees here, if you have a graphing calculator, you're going to want your mode to be in radians. Alright, so we're trying to get these curves down, and it's, hard figuring out since it's new material. So please reach out. Please send me an email. We can always, do those video chats online and set up a time for those. So don't be afraid and don't be ashamed. Just reach out, all right, and take care of it, all right? Hopefully I'll hear from you guys. Bye.